for complex analysis. Examples. Okay, everybody. Now let's give two complex numbers. One is Z1 equals 3 minus 2i, and Z2 equals minus 1 plus I. We would like to get Z1 plus Z2 and Z1 minus Z2, Z1 times Z2, and Z1 divided by Z2. We would like to get that. Okay? The first one, we are adding now two complex numbers, and as you will remember, you add the real parts and imaginary parts separately. 3 minus 1 is 2, okay? And then minus 2 plus 1 is just minus 1, so minus I. So the summation of these two complex numbers is just 2 minus I. The subtraction or the difference between the two complex numbers is just now you subtract the second one from the first one. 3 plus 1 is 4, and then minus 2 minus 1 is minus 3i. Okay, so the difference is this. Now the product, let's multiply these by using regular product. Okay, 3 minus 2i multiply by minus 1 plus I. So what we do is that we just 3 times minus 1 is minus 3, and then the other constant is written here in the middle. Okay, this one minus 2i times I is minus 2i squared, but I squared is minus 1, so that's just plus 2. Okay, so it's the product of these two. And then now the middle term is this times that, okay, this times this, and this time that. So now we have 3i plus another 2i, so it's just 5i. So plus 5i. So basically the product is minus 1 plus 5i. Okay, so the product is given by that. Now the division is going to be slightly more difficult. Okay, so it will be equal to 3 minus 2i divided by minus 1 plus I. Okay, so we don't want really the real complex numbers on the denominator. Okay, this is Z1 over Z2. So what we do is that we multiply the top and the bottom. Never forget this parenthesis. Minus 1 minus I, and then minus 1 minus I. As soon as you put this parenthesis, you have to do this also. Otherwise, mathematically, it will be incorrect. So multiplying the top and the bottom by the same thing, nothing is changed. But what happens is that the denominator becomes real. Okay, so denominator then is just minus 1 square, which is 1, and then I square with a minus sign is going to be plus 1. So 1 plus 1 will give you 2 on the denominator, and then the top will be just, if you do the product, minus 5 minus I you will get. So it's just minus 5 minus I over 2. So the division is slightly more difficult. Okay. If there is no questions, you can just text me the questions. Of course, I will let you ask you questions after the recording. Okay. So now we would like to show that this is correct. Okay. So in this example, we have now 3i to the power of 30 minus I to the power of 19 divided by 2i minus 1. Show that this is equal to just 1 plus I. Okay, this is 1 plus I. Show it. Okay. So now what we can do is this. Okay. Of course we will multiply the complex conjugate of denominator, but before, let's do this. I to the 30 can be written as I squared to the power of 15. Huh? Okay, because 2 times 15 is 30. Okay, that's good. Because I squared is something complex. Okay, what about I to the 19? This is minus, okay, I squared to the power of 9, okay, I squared to the power of 9, it gives 2 times 18, but we need one more I, so we just multiply by I like that, okay? So now divided by just 2I minus 1. Now you really understand what we are getting to, because I square is minus 1 and the odd power is minus, but the even power is plus, but both of them are odd, so that this whole thing will be minus 1, this whole thing will be minus 1, and this whole thing will also be minus 1, because the odd power of minus 1, because I square is minus 1. Okay, can everybody see it? Okay, then it's equal to minus 3 and then plus I divided by 2I minus 1. Okay, 2I minus 1. So what we do is that we now get the complex conjugate of denominator and multiply by the numerator. 2I plus 1, sorry, you have to change the sign of the complex part only. So minus 2I minus 1, as you see real part, you're not touching real part, minus 2I minus 1 on the top. So now this gives you 2I is just 4I squared with a minus sign, and it's just 4. Okay, denominator gives you 4, and then plus 1, 5. Always, this gives you always plus, okay? Summation of two numbers. The denominator is 5, okay? So what about the top? What about the top? Okay, so this is equal to now minus 3 times 2I is 6I, okay? This times that is plus 3, okay? Now this is minus, okay, minus 2I squared, but it's plus 2, okay? Now it's 5 again, 5 will be canceling denominator. And then the last term is minus I, it is divided by 5. As you see, this is 5 plus 5I divided by 5 is just I plus 1 plus I. So it checks. So as you see, this seems to be slightly complicated, but if you just consider I squared, whenever you see the high power of i's, you will use this I squared, which is minus 1. Okay, so this is it. So we solve this problem. Okay. Now we can show that another example here. In this example, show that Z1 star, Z1 plus Z2 star is equal to Z1 star plus Z2 star. Okay, this is how we have to do things. So how can we get this? So we will first get Z1 and Z2, add them up, and then take the complex conjugate. So Z1 is X1 plus I Y1, and then Z2 is X2 plus I Y2. Okay, X2 plus I Y2. Now we take the complex conjugate of the whole thing. Okay, now we are adding the real parts and the imaginary parts separately, so that X1, this is real part, X1 plus X2, okay, plus I Y1 plus Y2. This is general thing. Okay, so again we have to take the complex conjugate of it. So now, how can we get the complex conjugate of it? Remember that we have to change the sign of the complex part, but the complex part is just this part. So it is equal to the complex conjugate of the whole thing is just keep the real part exactly as is, and then change the sign of the imaginary part. Just that. Okay? Now, I will just combine this back into x1 minus iy1, but plus x2 minus iy2. Wow, this is just z1 star, and then this is z2 star. Basically, we showed it. So this checks. This checks. Okay. So we can also show that this is an example, and the last example for this part, okay, is this. show that Z1 times Z2 magnitude, okay, square is equal to just Z1 magnitude square times Z2 magnitude square, okay? So now, how do we do this? The product of Z1 and Z2. Look, if you have this product, we know that Z1 times Z2 squared is just the product of Z1, Z2, and by its complex conjugate, Z1, Z2 complex conjugate. That's it. This is how we did this. Remember that Z magnitude was equal to Z times Z star, okay, and square root. But now we don't have the square root because it's Z. This is square on the left. So if you have square here, you don't have the square root, which is the case here. Okay. So now what happens is that you just multiply this by each other because it's the product of just four things. But I'm just replacing this as Z1, Z1 star. Okay. And then Z2, Z2 star. Nothing changes. Though we can just change the orders of this product. Everything is multiplied again. But now, what? This Z1, Z1 star is just Z1 magnitude squared, okay, times, this is Z2 magnitude squared. So it checks. So this is also correct. Okay, now we are